we are continuing talking about CO8. It wasn't necessarily homework, but your job yesterday was to kind of get together in groups or individually and kind of work through this opening situation here. You got this table. It describes the time in seconds and the distance in feet an object travels. You were to kind of look for some sort of pattern, some sort of relationship that would allow you to predict the distance after 5 seconds. Okay? And then the real challenge, because we talked about algebra, is identifying and extending patterns. That's a big part of it. Is to figure out the distance of this object after 38 seconds without having to continue the table, right? Because 38 is really far from 5. Okay? So, first of all, what will the distance be after 5 seconds? 8. 144. And how did you come up with that?
So you do 16 times 4 plus another 16. And wait, hold on.
Shh. Just because you don't understand it doesn't mean he's wrong, right? And why 16 times 4? I'm curious where that came from.
Because, like, I don't really know.
Okay.
That's just how I figured it out.
All right. Priya, what'd you do?
B plus 32, which is distance.
Okay. So we're looking here and we see this common difference developing here, right? From 16 to 48 is 32. From 48 to 80 is 32. From 80 to 112 is 32. And so it stands to reason that 112 plus 32 would give us the next distance, which is 144. Okay? And we talked about, maybe we didn't talk about, maybe it was 8th grade, but what does the word arithmetic mean? Did we cover this yesterday? Okay, what does the word arithmetic mean? Oftentimes, like 1st, 2nd grade math is called arithmetic because what do you basically do in 1st and 2nd grade in math class, if you can think back to that? A big part of it. Right, you basically add and subtract. Okay? Arithmetic means addition and subtraction. What does the word sequence mean? Order or sequence, relation, also pattern. Okay? So we're essentially looking for an addition or subtraction pattern. Okay? And we found it. We're adding 32 to get to the next distance. Okay? And so how do you know in the math world, this is called a common difference. Okay? Common difference.
So you write that down.
You can write that down. Yes. All right, James. Way to give the effort. Okay? Common difference. And so you could add 32 over and 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 over again 38 times, right? Or we could write a rule for the table, some equation that will allow us to plug in the time we want, and the output will be the distance the object travels. Because maybe we're not only interested in 38, maybe we want 212. Okay? Whatever it is. So, who was able to come up with a rule or an equation, an expression that describes what's going on here? Okay? Gus, what'd you come up with?
Okay, 16s.
And what does S stand for?
Seconds.
Can I change that to time just because my S's look like 5s? All right.
Okay, plus in parentheses 16t minus 16.
Okay, so let's test this, right? We have a theory, we have a hypothesis. Let's test this with information that we know. Let's plug in 3, okay? If we plug in 3 for t, what should this expression equal? 80, right? Because that's a given. So 16 times 3 plus 16 times 3 minus 16, okay? 16 times 3 is 48. 16 times 3 is 48. Minus 16 brings us back to 32. 48 plus 32 equals 80. Okay? Now, Gus showed this to me yesterday, and I asked him to simplify it a little bit.
I did simplify simplify it with the distributive property. Yesterday was more complicated.
Okay, so are those parentheses necessary, first of all? No, right? Because whether we do this first or we add for it, there's nothing in there that says we have to have parentheses there. Because there's no coefficient to the parentheses other than positive 1, and having a coefficient of positive 1 does nothing. Doesn't change the sign, doesn't change the numbers. So we can rewrite this to be 16t plus 16t minus 16. And we'd still get the same answer that we got over here. Can we simplify this further?
You could add the 16 t's together.
And get what?
32 t's.
Okay, so 16t plus another 16 t's is 32t minus 16. James, you have a question?
No.
Okay. Did anybody else come up with an expression that's close to this or in the same ballpark? Yeah?
Well, it's not right, but I did addition first instead.
You did addition first?
I did it, yeah. I did 32, like 2 plus 16. but
Plus 16.
That's not.
It was up by
Right.
16.
What's that?
It was up by 16. Right? I couldn't figure it out.
Yeah. Yep. This 16 here, that minus, you are going back. Okay. Questions on this? Okay. This is the rule for the table. It's 32t minus 16. Okay. I should say it's one rule for the table, right? And so what would it be after 38 seconds?
1200.
You plug 38 in here. 32 times 38 minus 16. 1200 is your answer. Okay. 1200 is your answer. Questions on this? Okay. Now, if you struggled with writing a rule for the table, I've got your back. Sometimes writing a rule for a situation can be difficult. And making a table all the way to 38 seconds can be tedious. Luckily, there's another way. And it's what's called the arithmetic sequence. It is a formula that when you have a common difference, a pattern with addition or subtraction, allows you to predict a future result without having to try and come up with a rule. Are you interested in that?
Yeah.
Me too. Let's go. Okay. The arithmetic sequence is a pattern. I should say a common pattern. We'll talk about that word common. A common pattern with addition or subtraction. And we've broken down this phrase. Arithmetic means add or subtract. Sequence means pattern. Okay. I'm not talking about a pattern that's like +1, +2, +3, +4, +5. That's not a common pattern, right? Because you're adding something different every single time. A common pattern is +32, +32, +32, or -5, -5, -5. Okay, so that word common does come into play here, but arithmetic sequence is a common pattern with addition or subtraction. And here it is. It's a key point. It can go on a help sheet. I highly recommend that you put it there. AN equals A1 plus N minus 1 times D. Doesn't that look fun?
Yeah.
Okay, let's break it down here. Okay, so what did we do at the top, right? We were trying to find essentially the 38th term of our sequence. The time, if you recall, went up 1, 2, 3, 4, 5, etc., etc. We were looking for the 38th term, right? If you continued this pattern out, we were looking for the 38th term. So the AN, that represents the nth term of the sequence. The nth term of the sequence. Basically, it's the answer. Okay? The nth term of the sequence, it is the answer. We were interested in the 38th term. Maybe I asked you for the 50th term, the 61st term, the 17th term. Whatever term you are trying to find, that's why we use n, because we can use this to find any number in the sequence. And n just represents a variable. Or it represents a value, right? So for our purposes, what was n?
38.
38. Okay? We were looking for the 38th term of the sequence. That was going to be our answer. Our n was 38. It's the term you are trying to find. Okay? Which in our purpose, our example above was 38. Okay? A1, does anyone know what it means when you've got a small number that's lowered? It's not a power, right? Powers are raised. What's a small number that's lowered? You've seen this notation before. I know you have.
5 or more raises 4 or less.
No, not rounding. No, nothing like that. But you remember this formula here? y2 minus y1 over x2 minus x1. What do those? What did that 2 and 1 represent?
I don't know.
Evelyn.
The 2 is the second number and like the little.
Right, it's an order, right? First and second. So A1 with that 1 lowered, it represents the first term of the sequence. Okay? The first term of the sequence. Which, in our example above, what was the first term? 16. Okay? The first term, where we started, was at 16, and then we added 32 over and over and over again, right? But our starting point, our initial value, our first term was 16. And then D represents the common difference, there's that word common again, or the pattern. Okay? What's the pattern with addition or subtraction? In our example above, what was the common difference?
38.
Nope. 32. Okay? Positive 32. So, using the formula, this arithmetic sequence to calculate the distance after 38 seconds, it's going to look like this. Our answer, which is the 38th term, and I should actually write this A38 because we're plugging in 38 in for n, right? Remember that lowered number means an order. The 38th term is equal to our first term, A1, which is 16, plus, in parentheses, n, the 38th term, the one we wanted to find, minus 1, times, I'm going to put the multiplication symbol here, times 32. Go ahead and enter that in your calculator, exactly as you see it there.
And you do put.
So you don't put the A38 part in there because that's the answer. That's what your calculator will give you.
No way.
So it's 16 plus 38 minus 1 times 32.
So it's 38.
Exactly as you see it there.
What?
16 plus 38 minus 1 times 32.
38.
And you should get what?
1200.
1200, which is the answer, right? That's what we got up above. We've proven now this formula works. And Tatum asks a very good question. He says, why minus 1? Why is that minus 1 part of the formula?
plus we didn't have the minus 1 would be the wrong answer.
Oh, I changed
Why is the -1 part of the formula?
to like equal.
Gus.
Because you're using the number, or in this case, the time of seconds before it.
Okay.
Like if you were plugging 5, you would be using 4 to figure out what 5 is.
Okay, so this 16 represents the first number of the sequence. If we're looking for the 38, how many times are we adding 32 to 16?
1.
If 16 is the first number in the sequence, we want the 38. How many times are we adding 32? 37 times,
Oh.
right? Because we're starting at 16. That's our first term, not our 0th term, our first term. We add 32 to that 37 times. Now we're at the 38th term. So the -1's there because we're looking for the 38th term, but we already have the first. Therefore, we have to add 32 37 times. Okay?
Got it.
Questions on this? Has your mind been blown? No?
It's not like
I love guessing.
It's too
hard.
blowing in the way.
Let's practice a little bit here. Okay? It says write an arithmetic sequence of at least 4 terms using the given first term and common difference. So this just kind of gets you used to what these variables represent. What would our sequence be with an A1 of 17 and a D of 6? Well, what's the first number in the sequence? 17, right? That's what A1 means. Okay? That's where you're starting. And then if our common difference is 6, what number would come next?
6.
Remember what common difference means? This is the pattern. This is what's happening between each term. So if we're starting at 17 with a pattern of positive 6, 17 plus 6, 23 would come next.
How do we get 23? Just
So look back at your at your little definition part that we just filled out there, right? It said A1 is the first term of the sequence. So if I give you A1 is 17, I'm telling you the first term of the sequence is 17. The D represents that common difference, that pattern.
Oh, I get it.
Right? In our example way at the top, the common difference was 32 because you're adding 32 each time to get from term to term. If here the pattern is positive 6, that means you're adding 6 each time to get from term to term. So 17 plus 6 is 23. 23 plus 6 is 29. 29 plus 6 is 35. Okay? We're not starting with the whole formula because it's a lot. We're just starting with kind of the basics here. What's the first term? What's the common difference? What's the pattern? Evelyn, did I answer your question or did you have something?
I was just saying
Excellent. Okay, save it. So the thing to notice here is that from term to term, right, we're adding 6. That's that 6 comes into play there, right? And we started at 17 because that's the first term of the sequence that I gave you. Evelyn, we have a first term of -4 and a common difference of -3. So how is the sequence going to start? -4. And then if the common difference is negative, what operation would that? Subtraction. So what number would come next? -7. -4 minus 3 is -7. -7 minus 3 is -10. -10 minus 3 is -13. Okay? So again, just getting used to kind of the pieces of this formula here. That A1, that tells you what the first term is. And that common difference is what is the pattern. Okay? Last one. Write it out yourself. The first 4 numbers in this sequence with an A1 of 5 and a D of -11. What are those first 4 terms going to be? Aiden.
5, -6, -17, or -28.
5, -6, -17, -28. got the 5 because that's our A1 term, right? That's our first term. That's where it starts. We got the subsequent numbers because our difference, our pattern, is minus 11. And to get from each of these values, we're subtracting 11. Okay? Questions? There's a lot of confusion on this first one here. Did we get things figured out? So we're not quite there yet, right? We're just kind of building up to the full equation. Here, I just want you to understand what A1 means and what D means. Okay, we're not worried about the whole equation yet. Does this much make sense? Yes. Okay. If it does, then you're right where I want you to be right now. Okay? Let's move on. Now it says, use the given information to find the nth term of the sequence. Put the values into the formula to solve. Okay? So let's just write this formula out again. AN equals A1, the first term, plus n minus 1 times D. Okay? Now, what number of the sequence, what number term of the sequence are we trying to find here? N, which is equal to 12. So we can rewrite this to be A12, because that's telling us we're looking for the 12th term. And again, this is going to be the answer, right? The 12th term of the sequence. I also know that in my parentheses, it's going to have to be 12 minus 1, because that n represents 12. Okay? What number represents A1? Where are we starting? James? 6. A1 equals 6. That tells you this sequence is starting at 6. And we're adding 12 minus 1. And what is the pattern? 4. Adding 4 or subtracting 4? Adding 4. Okay? So it's going to be a positive 4 times positive 4. Essentially meaning that we're starting at 6 and we're adding 4 11 times. Why 11? Because 6 is the first term. We want the 12th term. It takes 11 hops to get there. That's why the minus 1 is there, right? So go ahead, put this in your calculator. 6 plus 12 minus 1 times 4. 6 plus 12 minus 1 times 4. Do you have a question or do you have an answer? Okay, make sure you bring it to class. Okay. 50? Do you have a second on that? 50 is the correct answer. Okay, so that A12, the 12th term of the sequence, is 50. Okay. The next one, A1 of 4, D of negative 3, N of 80. We're looking for the 80th term of a sequence that starts at 4 and subtracts 3 every single time. That's what's going on here. So our formula, A80 equals 4. Oh, sorry, I'm not plugging them in yet. But, okay. AN equals A1 plus N minus 1 times D. Okay. In this case, AN is A80th, because we're looking for the 80th term. That's our answer, right? The first term, A1, where it starts is 4, plus 80 minus 1 times what? Negative 3 times negative 3. That's going to cause this pattern to decrease, right? Because 79 times negative 3 is a negative number, and 4 plus a negative is the same as subtraction. Okay? So if the pattern is with subtraction, make sure you make that D negative. And what do you come up with?
Negative.
239? Negative 239? No?
No, I got
What'd you get, James?
2, negative 233.
Negative 233?
Yes, Taylor.
What?
Okay, we got some disagreement here.
Put in
Let's go to the TI-83 plus. See what it says.
Did you do minus 3 or negative?
Shoot, I did -3, not times.
Yes, make sure it's not minus 3. Negative 233 is the answer. Right? If you didn't get that, check your work. Negative 233 is the solution.
Well, I just put in 3 and added the negative sign, so maybe that.
That's what I
Maybe.
do.
Wait, how did that not work then? They don't follow.
I don't know.
I don't know
I'm
either.
gonna try it again.
Okay, last one. A1 of negative 50, D of 71, N of 101. Go ahead, set this up yourself. See if you can get the correct answer. I'll get the formula up here to start.
A101.
You're finding the 101st term of a sequence that starts at negative 50, and it has a pattern of adding 71. The 101st term of a pattern of a sequence that starts at negative 50, and you're adding 71 each time. How your equation should look. Your answer, the 101st term, starts at negative 50 plus 101 minus 1 times positive 71.
Put it in the calculator.
Exactly like you see it here.
What if I just put negative 50 in it?
So, okay. So clear it. Remember the negative sign is different than the subtraction sign? That might be where you went wrong first time. Remember, the negative sign is different than the subtraction key. Okay? There are two different keys. Mario, what'd you get?
7,050.
7,050. Do I have a second on that?
Yes.
The TI-83 agrees with 7,050. Anyone who did not
I
get
got it,
7,050, click and graph list. So that's why. Because you don't need to graph list yet. I want you to learn how to do it without a calculator. So this is a calculator you should get for high school, but not quite yet. A TI-83 plus.
Can you play games on there?
You can.
Should.
It's got a little port. You can download games from other calculators. So I spent most of my junior year in high school playing Snake instead of learning how to read graphs.
So you can still be our student. So you
Can you show us how to play Snake on it?
This calculator
on
doesn't.
your phone?
doesn't have it on it.
Mama doesn't.
Okay. Questions on this? Next section says determine if each sequence is an arithmetic sequence. If it is, identify the values of A1, N, and D, then find the nth term. So this is asking you, it says find A12, find the 12th term of 15, 22, 29, 36. Now this arithmetic sequence only works if you have a common pattern with addition or subtraction. So before you do this, because I'm going to have to do this yourself, let's just decide, is this an arithmetic sequence, and tell me why. Yes or no, tell me why. Aiden.
Yes, because you're just adding something.
Right. Yes, because it's a pattern with addition, and that pattern is common, adding 7 each time. Next one. 1,024, 1,976, 952. Is it an arithmetic sequence?
Yes.
Why not?
It is.
It is.
Why is it?
Because you're subtracting 24.
Because you're subtracting 24 each time. Okay, that difference is common. It's a pattern, and it's with addition or subtraction. Next one. Find the 20th term of 7, 8, 10, 13. Is that an arithmetic sequence?
No.
Why not?
Because it goes up from 1 and then up 2 and then up.
Because what would you put in for D, right? What's the common difference? There isn't one. It goes plus 1, plus 2, plus 3. The pattern isn't common. So you cannot use the arithmetic sequence for that question. It will not work. So there's nothing to do there.
Yay.
Okay? Just cross it out. Find the 48th term of -1, -12, -23, -34. Is it an arithmetic sequence?
Yes.
Yes. Why?
Because
Because the pattern is subtracting 11. Okay? Then you've got, when will I ever actually use this in life? Your bank account currently has $160 in it and considered today day 1. Okay? So what is in our formula, what does that make 160? If this is day 1,
common pattern.
They're A1.
that's your A1. That's your first term. Today you're starting with this. Okay? You begin adding $8 every day. What does the $8 represent? The D. That's the pattern, right? You're continuously adding $8 each day. That's the common difference. How much money will be in the account on day 50? What does that represent? N. That's the nth term of the sequence, right? So in word problems, like we've seen before, you've got to pick out what's the information that's important and how does it fit. Here we go. Now you've got those 3 pieces, you can write the formula. Okay? On the first day of school, you bring a jar of 1,243 jelly beans and, starting the next day, eat 11 each day. How many jelly beans will be left in the jar after the 31st day of school? So you don't eat 11 the day you bring them. This is still your A1 though, because that's what you're starting with. But then the next day and every day thereafter, you start subtracting 11. How many will be in the jar after 31 days? Then to train for an upcoming marathon, you run 1.5 miles on the first day of training and increase that distance by 1/8 of a mile each day. How far will you run on day 30? And don't miss this, your answer needs to be written both in miles and in feet. And if it helps you, there are 5,280 feet in a mile. There's your conversion factor. So we've seen a question like this before. We had to convert seconds to days. Okay? Here you're converting miles to feet. And there are 5,280 feet in a mile. Questions on what you are to do. This is due tomorrow. Tomorrow you'll get your practice test. We'll have the day to work on it. I can also go over some math fact questions if you have them. The practice test will be due on Thursday. You will get an answer key, so there should be no excuse for not getting it done because I'll give you the answers. But you'll turn that in on Thursday. I'll give you the test Thursday and 2-day test if you need the time, Thursday and Friday. Since we only have 45 minutes, we can't extend time like you probably could do last year, so it's just a 2-day test. The help sheet that you bring in, doesn't matter how many note cards or whatever. If you bring in a loose leaf sheet of paper, it doesn't make a difference. Just make sure you have no worked out examples on the note card. You can have any definition. You can have any key points, such as the arithmetic sequence. That was a key point. Our table of perfect squares from CO2. That was a key point. That can all go on there, but nothing actually worked out. Okay? Nothing actually worked out. Yes?
Can you do one of the one in the middle?
Sure. Which one would you like? What? Sure, the first one. Okay. So it says find A12, and what variable does that 12 represent? It says find the 12th term. AN. Okay, AN. It's asking me for the 12th term. That means the number I plug in for N in the formula is going to be 12. Okay, my A1 is the first term of the sequence. And the first term of the sequence is 15. There's my A1. And then going from number to number, what's happening from 15 to 22, 22 to 29, 29 to 36? We're adding 7. That's my D, right? So now plugging all those things into the formula, AN equals A1 plus N minus 1 times D, or A12, that's the 12th term. And notice I replaced N with a 12 here. So in the formula, I'm going to replace N with a 12 here. And Okay? My first term is 15. My common difference, my pattern, is positive 7. That's what goes into the calculator. Because you're starting at 15 and you're adding 7 11 times to get to term number 12. That's what's happening here. Okay? All right. Other questions, comments, concerns, complaints, comments, congratulations, or criticisms? Very well. James?
I know.
Okay. That's our math, folks.
Don't forget to
Like and subscribe.